So there's this incredible triad, which includes the left dorsolateral prefrontal cortex, the cingulate or anterior cingulate cortex, and the insula. And those three are working together in a kind of conversation. It's a neural conversation, but a conversation nonetheless, trying to figure out, okay, what's going on inside me? How do I feel? What am I thinking about? And this could be thoughts about the past or the future or the present. They are also in a conversation as to whether or not the sensations that you're experiencing, meaning how quick your breathing is or how slow your breathing is, how your heart feels, how your skin feels, any sensations of pain or pleasure for that matter, whether or not that makes sense for the situation you're in, and trying to determine whether or not you are doing the right things as a consequence of those sensations. Okay, so again, if you can't remember the names of these different neural structures in the brain, don't worry about it. It's really not that critical. What is critical is that you understand that there's a conversation that's constantly occurring as long as you are awake, trying to figure out what's going on inside of you and whether or not it makes sense relative to what's going on outside and around you. Now, humans are smart. That is, we are, to some extent, conscious of the fact that we have memories of the past, awareness of the present, and anticipation of the future. So we do realize, for instance, that we can be seated at the dinner table, and have a thought about something tomorrow, maybe an exam that's stressing us out or something like that, and that will change our bodily state in a way that is not optimal for what we're doing in the moment, but that can still make sense to us because that exam is important. Maybe we're feeling some pressure about a hard conversation we have to have, or maybe we are very excited about the next day and we can't eat because we're so excited. And that can make perfect sense to us because we do have access to this knowledge about self that we can think about the past, the present, or the future. So that makes the conversation these three structures are in even more interesting and dynamic, because what it means is that we can be doing something, eating, talking, running, any number of different activities, and our bodily state may or may not match what we are doing in a way that's adaptive for that. And yet that can be completely okay, or at least understandable for us. Now, a major emphasis of a meditation practice is to make us so-called more mindful. What is mindfulness? Well, again, there isn't one perfect, universally accepted operational definition of mindfulness. That's basically nerd speak for saying people can't agree exactly what mindfulness should be, is, and means for everyone. But most people assume, and I think agree, that mindfulness includes something about being present. And when I say present, that doesn't necessarily mean present to one's surroundings, because of course a lot of meditation practices that are designed to make us more mindful and present are designed to make us more mindful and present to what's happening internally while ignoring everything that's happening externally. But they are designed to make us more present to our bodily sensations, and in particular our breathing and our thoughts in the moment. So let's now explore what a generic meditation practice looks like, and let's evaluate how that tends to change the activity of these neural circuits in the brain and body. And then from there, we can split the conversation into a couple of different bins. That is, meditation practices that are ideal for enhancing focus, meditation practices that are ideal for improving mood, meditation practices that are ideal for improving sleep, and meditation practices that, believe it or not, benefit all of those things in one fell swoop. Okay, so what happens during a meditation practice at the neural level? In order to answer that question, we are going to be scientists. That means you and I are going to be scientists now. We are going to break down a practice into its different component parts and address what we know for sure about the brain activation states that occur with those different component parts. In order to do that, let's use a somewhat generic form of meditation, but it's generic and pretty far-reaching, because I would say that for most people, about 75%, let's say, a meditation practice is going to involve stopping, meaning getting out of motion, sitting or lying down, and in most cases, closing one's eyes, although it is absolutely not required to close one's eyes during meditation. There are many forms of meditation that are done eyes open. But for most people, it's going to involve stopping our movement, that is, not ambulating, not walking or running, so seated or lying down with eyes closed. When we do that, meaning when we sit or lie down and close our eyes, as trivial as that shift might sound to you, it actually is a profound shift in the way that your brain and other neural circuits in your body function for the following reason.